Okay, so I have this idea that I can show you visually by doing this. So, you can call it a virtual peer tutoring. But anyway, just gonna have to, I really do want to show you how this works. Also, at the same time, help you understand and learn how the inner workings of assembly code actually works and what Professor Milham wants us to understand. So, in that case, let's get started. So, in question number 4, it tells us to write an assembly code. An assembly code that contains a memory location, F3C4, and B at its memory location, CD D2. Now I assume that you know load and store, as well as add test greater than branch greater than branch always BR. If you don't know them, don't worry, I'll explain it step by step, line by line. So assuming that you have read the instructions already, I'm just going to go straight on ahead and start writing down what you need to do. First, we want to start off with line 100 because it says that we can end up at line 200. Now you can start off at line 50 or line 1 or line 0. It doesn't really matter as long as it comes to either ending whether the condition is true or ending at line 200 when the condition is false. I'll explain that in a moment. So back to that, in line 100, we first going to have LD load, and in the instructions it tells us that F3C is A, and we have to use registers in terms of R1, R2, and so on and so forth. So I'm going to write this down, and then I'm going to explain. Now this is the format of how it's supposed to look like. And to explain this, so A as we know is this. And B, well, we're going to do the very same thing. And B is that. Now, when I use the word load, I'm telling my assembly code, retrieve the variable A in memory location F3C4 into the cache or into the register memory, which is right next to your CPU. So, and put it into register set number 1. So what the computer does is it goes all the way to your main memory. It collects that variable A, which is this one right here, and then it takes it all the way to register R1 inside your cache. So that's what this line of code means. Our next line, actually we can just improvise there. We are also going to be loading this and calling this one R2, putting B in register 2. Same thing, same story, no difference. Now in the next one we have to assign in values. Now you can either say load values or move values. It's just that it's going to be one and the same, because remember, in your code, you have mentioned that A is equal to 3 and B is equal to 0. And remember that R1 is A and R2 now is B. So we have to take these values and put them into R1 and R2. So we're going to be using load as well, or we can just use move. Move is a lot more better. So MV for move, R1, and remember in the assignment it says that we have to use the hashtag key. So the hash to precede the value. So instead of saying 3, we're going to say hash 3. And then line 130, move R2, which is B. So move the value 0 into R2. Now you got two registers which have both the variables which is declared as integers, and the values which have numerical numbers in it. Now the next thing of what we're going to do is we're going to do our tests. Now our test is going to be like this. Testing is when you're using your conditions. Like if you can remember, if A is greater than 0, then B is equal to the math statement that plus that. If you can remember, let's not forget about the semicolon there. So we're going to translate this into assembly code right here. But we have to first test it out. We have to first test the condition. That's our if and our condition right here. Then if it's true, then we can go on to this one there. If it's false, then in G it says that if the condition is not met, branch to line 200 when nothing occurs. Use the command HLT, halt, to indicate program ends. So with that being said, when it comes to conditions, we are going to play with tests. STST. And what are we going to be testing? We're going to be testing if R1 is greater than the value 0. So we can just do this. We can say R1, comma, hashtag 0. Or you can say R1, comma, you can just do this, R1, comma, R2. Because remember, B has the same value as B has this value of 0 as well. So before you actually jump onto this, just to give you a quick indication, everything that I've written so far is according to what the assignment is wanting you to do. So there are your line numbers. Here are like your commands, your action commands. Here on the left hand side of the comma is your destination, and here on your right hand side of your comma is where your source is. Just as mentioned in the text, will not mention in the textbook, but well, you get the idea. Anyway, let's continue. So we see that we have to test R1 if it's greater than 0. So in line 150, we're going to say BGT, branch greater than. And with BGT, we have to branch it to line 170. Now the reason why I said line 170 is because this one here represents as true. The next line, however, we have to represent something that is false. And where is that line going to jump to? So that gives us the perfect opportunity to say line 160, BRA, which means branch always. So that can also mean false. BRA to line 200. Now BRA line 200 means that that the variable must not equal to 0, but it must always be greater than 0. So if A is equal to 0, then that is still false. Therefore, jump to line 200 where we have the word HLT, halt, to stop the program, and it will end. So that's line 60. So let's go on to line 170 and continue of what happens when the variable is greater than 0. So here, when we have this, if this is true, then we can go from our condition to our math statement, which is like this. You know that R1 is our A, and also we have to use the add command, and also we have to use the value 3. We add all of that together and we assign that value into R2, which is the new B, and then store B back into the main memory, which is that right there. So to finish everything off and explain at the same time. So here we're going to say add R1, which is our A, to hashtag 3, which is the value 180. We're going to move R1 into R2. So R2, R1. So the new value R1, which is 6, because remember R1 A was 3 and now 3 plus 3 equals 6. R1 is now 6 and it's moving into the value R2, which is B. So B has a new value which is 6. Then finally, to end the program, which is true, you're going to say line 190, and then the opposite of load is store. So you're going to be storing it back into your main memory. So you're going to say st store R2 back into C2D8, which is the variable declared for B. And then you're done. And now it's stored back into your main memory. Now, let's not forget, we still got 200 to solve. So line 200, and voila, it's done. It's finished. So this is how number 4 is going to look like. Like I said, you can be able to change it. This is what I've written down for my assignment. You can be able to change it. You can have 1,000, 2,000, 3,000 and end off with just 200. But I would suggest to go from ascending order, so 1, 2, 3, 4, 5, 6, 7, 8. And you can even make those huge leaps. Also, do not forget about your command lines. Do not forget about your destinations, and do not forget about your sources, as well as which line number you have to jump.